Hey, not bad. How are you? Thanks for joining me.
I'm doing pretty good. Yeah.
Yeah, super excited to have you on the pod. I think we're sort of in like a similar Twitter circle or something. So I just been seeing your stuff for a while, and I always wanted to reach out. So thanks, thanks so much for
Sure.
finally making it happen. So I mean, oh, go ahead.
Yeah, I think it just got lost in the message requests, so I just never saw it until a week ago or something.
Yeah, exactly. You're just too
Yeah.
popular. No,
No, no. It's mostly spam.
the thing I wanted to start with, and the thing that sort of I think one of the things that I really like about this situation is that I can find internet friends that reflect some of the values that I really. And so I found one tweet of yours that said, I think the only way I'm going to have any sort of meaning is from working at a hard tech startup. Or it was something like that. And I don't know if you remember it.
Sure.
And so I just wanted to start there because I thought that would be just a good like launching off point. So what prompted that tweet, and what were you thinking when you said that?
Yeah. What I meant was I could I could go work for another company or end up just doing a normal job. But I really think that experiencing struggle and having to overcome something and having that constant challenge provides a sense of meaning and purpose in life. And it allows you to, if you think of it like a video game and you beat the video game, it gets boring. And so you always want to find like a new level to or a new boss to beat or something. And I really think that for me, I'm always interested in engineering, and I'm always interested in not just like one discipline. I like mechanical engineering, I like electrical engineering, I like software engineering. So for me, going through a career would be quite slow, and the role I needed to get is a systems engineer, and that takes years to get to that point where you're an actual systems engineer working on actual systems engineering problems. And so I think that by being a founder in a hard tech space, not only am I able to tackle problems from an interdisciplinary standpoint, but also there's extreme accountability, right? Like ultimately, you can't blame something else if you fail. Yeah, there's no way of escaping your problems, and so it forces you to tackle them head on. And I think that's just great for personal growth.
Mm-hmm. Yeah, I started working at a YC startup called Blissway 2 weeks ago, and I've just had to do all sorts of random things, ranging from working on the web page to thinking about ML models that we can deploy and all sorts of stuff like that. And so my question for you is, and so I definitely see how that working at a startup, you can make it so that you're doing everything, because I'm sure that you're doing even more than those three things that you just mentioned. You're thinking about the business side of things. You're thinking about copywriting and marketing and so much. And so I have heard about, I'm afraid I'm going to mispronounce the name of your
Don't worry,
startup.
go ahead. Everyone mispronounces it. You're fine.
Yeah. I think it's like Vuecason. Is that what it is?
Vuecason.
Yukasan. Okay, that's much cooler. And yeah, I'm just interested in what's your vision for that company? Where building metal printers is such an unbelievable idea. Like, where did that even come from, and where do you want it to go?
Yeah, I guess I'd just like to point out that metal printers, they already exist. It's just that what's out there is either not affordable or not able to offer the performance at a low cost. So it's not that I'm inventing something that doesn't exist. I'm just inventing a new method of metal printing that could open up the use cases, and it'll be more accessible to different types of customers. Yeah. So the goal of Vuecason is really just to make a metal 3D printer that can print metal like plastic. I don't know if you've ever seen a plastic printer before, but it has this nozzle, and then you have this plastic filament that goes in, and it just comes out of the nozzle and moves around. It's almost like a hot glue gun on a motion system that goes layer by layer, laying down the plastic. And I think that the thing is with metals is that generally that type of method doesn't really exist. You generally have all these really expensive powder-based metal printers that cost $1 or $2 million and usually are extremely low, or extremely slow. And then when you think of the material cost for them, it's like maybe $500 a kilogram for titanium or something like that, which is like a huge markup. And I think that going back to the way plastics are printed and trying to do that with metals is a way to radically reduce complexity in the machine and then reduce cost and expand metal printing capabilities for more people. We're still focused on building like a professional grade printer for sure. This is not like a hobbyist printer, but at the same time, it's going to be low cost enough that more businesses will have access to it other than just the supercar makers of the world or like the SpaceXs of the world.
Yeah. And that was my next question, is that if Vuecason succeeds, what do you want the world to look like? What do you want its impact on manufacturing to be?
Yeah. So I'm sure you're familiar with the stagnation kind of argument.
Yeah.
So I think that Vuecason's like this crusade against stagnation in a way. I would say that after regulation, what really comes down, the reason why we're really stagnating is because of manufacturing and just the cost of producing parts or producing design changes. I think in the software industry, you have the IDE, you can like type out code, and if it doesn't work, you run it, you'll know instantly. And you can just like brute force and just keep going and like figure out what's going wrong and learn that way. You can learn through iteration. With mechanical engineering, that's a much slower process. It's easier to do if you're just making one part or if you're making one single prototype. But generally, companies are not making like one prototype. They're trying to build a product that can go to market and be manufactured at scale. And if you make one design change, you have to basically design entire sets of new manufacturing tooling in order to support that design change. So it's like incremental improvements each year because they want to only change like maybe one part of the machine tool, like one part of their manufacturing process. They can't start from scratch every year and do something entirely new. And what's nice about metal printers is that basically they're slower than your like super optimized manufacturing line, but there's really no cost in switching to a new design. It's like this kind of general solution. If you think to give a computing analogy, I would say that conventional manufacturing is like an ASIC and your metal printer is more like an FPGA where you can change how to do things and you don't have to change the hardware.
Yeah, I like that analogy because it's so powerful. I was just thinking about it in terms of a software sense. I guess there's this idea of, the flow state. And if your IDE isn't set up correctly or you have to, do a ton of things to rebuild the code every time, then you don't get into that flow state and you can't make changes fast. So I love the way that you phrase that there. And so I saw that Vuecason is remarkable for me in that way because I see there's a lot of applications going to push a lot of other things forward and we can get out of the Peter Thielian, I guess, stagnation. But I saw that you applied to Y Combinator last September.
Yeah.
I was just wondering what went into that decision and what were you hoping to get out of it?
So I knew it was like first of all, it was like way too early, especially for a hard tech company to go apply to YC, in my opinion, at that stage. But I just wanted to do it to like force myself to articulate what I had in my head and just go through that process of just writing down the application and submitting it. I actually talked myself out of it and then changed my mind last minute to go ahead and submit it anyway. And honestly, it's like a good way of time-stamping progress because I can look back at the application and see the goals I wrote down there and then see if I actually fulfilled them. It's not just like a private, I have my own schedule that I write down internally and my personal notes, but to have it like time-stamped in their application system is just like a good way to set goals in stone.
Yeah.
And so that was like my reasoning behind it. I think that YC is more structured towards companies that are ready to take LOIs and start focusing on customers and sales, which is extremely important, but I'm still heads down for just entirely focused on R&D and just developing out the technology.
Mm-hmm. Yeah, I love it because even if you fail, it's sort of like a great thing. It's, if you think about like Cortland Allen, the founder of Indie Hackers, he applied to YC, I think every year that he was in college and got rejected every single time. I think it's an excellent process, but that's the distinction you pointed out was one that I wasn't actually entirely aware of. But you mentioned the stagnation, of course. And one of the people that I interviewed earlier was Rahul, who obviously has published his book. And he's the first person that really got me excited about hard tech and the potential of hard tech. So I was just wondering if you could talk a little bit about the need for hard tech in our current moment, the ways in which hard tech can drive so many things outward, break progress and technology from just being outside information technology and to just help us expand into so many other things.
Right. Yeah. I'll say this first. I don't think that we should be taking like resources away from software and like funding software innovation and trying to put it into hard tech. I just really think that we should be allocating capital to hard tech and like continuing to develop software. Yeah, just say that up front. But I do think that I'd say with hard tech, there's just a lot of fundamental problems that can be like solved, and things change over time. So you'll see people who've tried to tackle different hard tech problems 50, 100 years ago, and then they'll fail, and nothing's been really, hasn't been any serious progress in that, maybe like that space since. And then you can come back today and see, okay, we have modern technology, we can apply new things, new methods, and see if this is actually feasible now. And to give an example of that, like Hyperloop, still there's no full system today, but the idea of having a vacuum tube train has been around for several years, several decades. It's not a new idea. But now that we have more modern control systems, we have more advancements in magnetics, magnetic simulation, the barrier to like developing a Hyperloop system is a little lower. And so we're starting to see like student competitions where 50 years ago, that would have been unimaginable.
Mm-hmm. That you're a part of, right?
Yeah. So that's like the one example I wanted to go with. But yeah, I think that in general, it's just, and also I'd say that I think people tend to think, oh, we've solved all like the hard issues, all the low hanging fruit in hardware has been picked. And I just don't think that's true. The tree's always growing. Like, I think that in retrospect, all the past hardware innovation looks pretty simple because we already know all the answers. But if you were to go back 100 years or if you're born 100 years ago without any knowledge of today's technology, all those discoveries would have been equally difficult. And so I think that the idea of, oh, we can't, all the easy things have been solved and all the hard problems are hard isn't true. I think that it's always this moving, like, I guess, like perception's always moving, and it's all relative to your current technology. So the next like big, really hard tech problems aren't going to be, they're going to be like new things. I think, I don't know if you've talked to Garrett, but like the thing they're doing with tunneling is really cool. Like the boring company is doing tunneling as well. Tunneling's been around for, like, I think the first tunnel boring machine's been around since the 1950s or something like that. And we haven't seen a lot of tunneling innovation. And that's because people just aren't thinking about that. Like when we think of startups, we don't think tunneling usually, or like infrastructure. So I think it's just taking the mindset of how you run a startup company where you're like focused on incredible growth and something incredibly disruptive, and applying that to like heavy industry or like industries that they use technology, but they don't really move fast, is like a valid approach for hard tech and going that route.
Mm-hmm. And yeah, I see what you say about the best heuristic that I ever heard about it was, I think it might have been from Sam Altman, where he just talked about creating a startup that is aligned with your vision of the world and the future that you want to create for other people. And I'm just interested in what problems that you see hard tech solving, or maybe another way of phrasing that is just, if you weren't doing Vuecason right now, like what other problem would you want to tackle out there?
Yeah, I would say that, I think developing custom hardware for like CFD or FEA simulations would be pretty cool. CFD is like computational fluid dynamics, and then FEA is finite element analysis. These are like different simulation technology that's used to like simulate designs on the computer. And hardware acceleration for these things exists, but it'd be cool to see some more custom ASIC or just FPGA development there. I'm sure there's stuff out there already, but yeah, I would say that's one cool area. I would say that I think tunneling is really cool, or something with Hyperloop is really cool as well. But I think you have to have a strategy for navigating the regulatory environment for that. I think that, I would say that like with Hyperloop, a lot of this is just held back by your environmental regulations when constructing something new, some zoning laws. I'm not saying like the environment is important, but these things do get in the way of, or at least slow down Hyperloop development, which is why we've seen it in like the press a lot, but there hasn't been a system that people can actually ride on that reaches full speed yet. It's not really a technical challenge really there. I think that there's just a lot of work that needs to be done in energy. I think not only just power generation, but also energy storage. I think that we'll see like a lot of opportunities for small scale like nuclear reactors, that if you go like below, I think like 10 megawatts of power, you can avoid some of the regulations in terms of like how close you can be to a city, and you can just build out clusters of that and get around some of the regulations there. And I think that might be one way to go. And I honestly think like nuclear, like everyone talks about nuclear fusion. I think there's plenty of stuff that can just be done with fission, and we shouldn't really wait or fear that. And then I think geothermal also could be really big, but I'm not really too familiar with that space.
Yeah. Yeah, in particular, nuclear, I think, is underutilized in terms of reducing energy dependence on fossil fuels, and we don't talk about it enough. And right, even the Green New Deal actually did not include nuclear in its proposal, which was
Right.
puzzling. But I think it's so exciting because I actually never really considered, I always considered information technology as technology. And so I viewed all the innovation that sort of came in that space. And when I learned, and it seems so silly now, but that there's actually so many other problems to solve, I think just the scope of the possibilities out there expanded. And that was really exciting for me.
Yeah, I think that information technology can just permeate all the heavy industry and hard tech problems as well. So it's you can use software to help solve really difficult problems with atoms. It's not just confined to things on the computer.
And you just talked about it, right? Running various simulations. I think that would be particularly useful in a nuclear reactor type setting, or in manufacturing settings, using some AR or VR to understand how we would
Right.
interact with materials before we actually create them. That could help the iteration process too. Yeah, I definitely agree with you. I think that work is super valuable, but it's just there's so much work to do. So it's pretty exciting.
Yeah.
Um, I'm interested. So this is a sort of a simple question that's actually getting at a broader question. So I'm interested in just the origin story of Vuecason and whether you thought you would make as much progress as you have. And then the next question I'm going to ask after that is just about how it feels to think of something in your head and then actually see it manifest and come to life.
Sure. Yeah, I think so. I was just really obsessed with plastic printers originally. I first got introduced to like 3D printing through the robotics team at my high school. And the day we got the 3D printer, it changed the way we made everything forever. Before that, we were cutting things by hand and bolting them together and having to rely on kits. And then when we got the 3D printer, we could just design things on the computer and then just have a part in that exact geometry come out overnight. And I think it just changed what we could do forever. Like we could build just things that are far lighter, far more complex, far higher performance than before. And I think that's where I started to realize, oh, okay, 3D printing can really make things easier for prototyping. And when I was in college, I ended up running the College of Engineering's like 3D printing lab for a while, just like managing, it was like almost 30 printers and just running that shop basically for undergraduate students. And yeah, so I got to see what people were working on and just seeing what they're printing and how much people actually understood of printing, even within engineering, and just seeing what they could do with it. And so I thought, okay, this whole we have 30 printers in there, that's like inefficient. It'd be much easier for my job if I just had to manage like 2 or 3. I was just thinking in the back of my mind, like, what are some ways to speed up plastic printing? I originally thought, okay, let's try to find ways to speed up plastic printing and focus on that problem. And so I was just reading up on that. And I realized that we could make plastic printing maybe 10 times faster. There's one research paper that came out of the MIT mechanosynthesis lab where they used like a laser to heat up the plastic, and it was still through a nozzle and it'd move around, but it was just much, much faster. It's 10 times faster than your traditional plastic printer. And even though that's really cool, it wasn't cost effective for commercialization. And on top of that, when you're in plastics, you're competing with injection molding, which is like a much faster traditional manufacturing process. And the difficulty to set up an injection mold for plastic is far lower than something like sand casting for metal. So like the added benefit of additive manufacturing is still there, but it's just not as high. I think that plastic printing is still incredibly valuable even for production, but there were also like a lot of other people working in the space, and I felt like they could pull it off. And so in my search of looking for how to speed up plastic printers, I came across like a few like forums where people were talking about using an induction coil to heat up the nozzle. So the way that nozzles currently work is they have a current that runs through the nozzle through like a heating element, and that warms up the nozzle, and the heat transfers from the nozzle walls into the filament material. Mm-hmm. And what they were doing was they had this induction coil which would induce a current into the metal nozzle, and the nozzle heats up that way instead of running wire directly through it. There wasn't really much of an advantage, to be honest, there, but it got me thinking, oh, what if we could use an induction coil for metal? The thing is with metal is it's already conductive. You're already able to just induce a current in the metal directly. So you can heat up the metal directly instead of having to rely on the nozzle. And the heat transfer, like the time it takes for heat to flow from the nozzle walls into the filament material, is a huge rate limit for printing. And so if you're able to produce heat in the material directly, that can be a huge advantage. So I thought, oh, what if I could just work on metals then? Because that's like far more valuable, could provide a lot more value for aerospace customers and manufacturing tooling. That's what stagnation actually is. And it suited like my background a bit as well, because I was really interested in power electronics and firmware, as well as like spending time in like machine shops and stuff. So it became this perfect intersection, whereas, okay, I can make something incredibly useful if it works. And that's how I got the idea for using an induction coil in a printer. I would say that I actually ditched the idea for a while after that. I was like, okay, this is like too obvious. Someone must have figured this out already. There must be like some reason why this doesn't work, and I must be missing it. And yeah, there's like tons of different problems that need to be overcome, but I don't see any like fundamental issue with using an induction coil to 3D print metal. Just a ton of like really hard problems. But yeah, so I did that. And then in between that time, I was just reading up a lot on the manufacturing industry, the additive manufacturing industry. So that's like the industry term for like 3D printing, and like understanding, okay, why hasn't, when software, we talk about how like software is going to eat the world. Like, why hasn't 3D printing eaten the manufacturing world yet? Like, why haven't we seen, like, we've seen all these like articles since 2013 talking about 3D printers, how it's like a Star Trek replicator. You can make anything you want, and you don't have to do much. You don't have to put much thought into it, and everything will be manufactured with 3D printers. And that just didn't happen. And I think, first of all, manufacturing is like a industry that iterates slowly. You're not going to see that happen overnight. But also, I don't think that the 3D printing technology out there is just that good. Mm-hmm. And so it's not really like living up to the claims that are perpetuated in the media. And so, especially when people don't come from like a manufacturing background, they think, oh, they can make one part, now they can just make anything. And that's very far from the truth.
Yeah. Yeah, I guess it's difficult, particularly when different components have to work together. Even Tesla, who I guess we think of as, right, the gold standard of manufacturing, because I think they're far ahead of anyone. They have to do a lot of manual assembly too. Yeah. I don't know if that's necessarily what you're talking about, but I think it just shows that it's difficult to get different components to work together.
Yeah, certainly an example. And also the thing is with Teslas, if you hear Elon talk about the electric fleet, this is something that will take 10, 20, 30 years because it takes time to swap things out, especially with cars. Like, you expect them to last 10 years. Mm-hmm. And then depending on the machine tool, a lot of machine tools are like that as well. Your expected lifetime is closer to 5, 10, 15 years. So things takes a lot of time to phase out. So that's one reason why. But I think really it just comes down to the printing technology is just not living up to the claims that we promised.
And I guess that's really exciting because you see an opportunity there. And I guess, what's it like just being a founder and doing that day-to-day grind and solving those little issues?
Yeah. I think like right now for me, it's just like figuring out what other problems I'm just not aware of. There's just so much I don't know. So I'm spending like basically the next like few months just trying to figure out, or just trying to prototype and hit a bunch of roadblocks. And then I'll be aware of, okay, here's the problems. And then I can have a rough idea of, okay, I need to hire this many people, these specific engineers with these specific skills, and then raise enough capital to, pay for their salary and buy the equipment and do all that. And I think with software, you can get away with it because you can make mini pivots really quickly and change things and like navigate and weasel your way around a lot of problems. You tend to deal with a lot of like business model issues instead. But with hard tech, it really comes down to if you can build what you say you're going to build, and the cost is low enough that people can afford it, there isn't much market risk. It just comes down to like technical risk and being able to execute on your plan there. This is just me figuring out and scoping out like all the issues. And so that's what the day-to-day looks like is, okay, I thought this would work. It doesn't work. What can I do as an alternative? And for me, I'm really focused on developing. So I'm in the process of developing like the actual print head right now. And so it'll take a lot of time to get to the point where we're actually doing like actual 3D printed parts. I'm hoping that by end of March that we'll have like a demonstration that we can do 2D layers. It's like a single layer of a part out of metal. And by doing that, I'll have identified a ton of the problems that I talked about already. But I think that going through that process and developing a system where you're able to collect data off of the print process and characterize a lot of the issues is like a lot of the thinking you have to do. And so it'll help me kind of form like an idea of what I have to build in that area too, in order to automate the iteration process in designing the machine.
Mm-hmm. This is really exciting because it sounds like you have a definite plan for where you want to go. Do you get people just like clamoring to ask if they can help you build what you're building?
I get some people on like Twitter DMs from time to time.
Yeah.
Yeah. And it's honestly like everyone on Twitter is like super kind and helpful. So yeah, I'd say, yeah, generally like I get it a couple times like a month, people will reach out and ask, hey, is there anything I can do to help? And so I think that's one thing that makes hard tech a bit easier, is that it's easy to attract like people to support you or employees to work for you because you're offering something that's just like shiny and like fun to work on. Yeah. Sorry, go ahead.
It's completely new is what I was going to say. Who wouldn't want to work on something that if it works? And that was going to be my next question is, what do you think it's going to be like, or how do you think you'll feel when you actually see the first Vuecason printer or something like that? And when that idea in your head actually becomes a reality, but yeah, offering someone that, how could they not get excited?
Yeah, absolutely. And yeah, I think like seeing like something you've imagined in your head and then like actually being able to hold it and see it work in person, and this is tangible thing, is one of the like best feelings in the world. Even if it doesn't work the first time, like it's frustrating, but you're still struck in awe a little bit and saying, oh, okay, this actually exists now and I can hold it. And it's one of the best like rewarding feelings ever. And that's partially why I just like building things a lot. Like I enjoy software, and it's fun to see, even you get that feeling too when you're building an app or like a website and you gotta run it and it actually works. It's so fun. But then seeing it in person with parts is just like an entirely different experience, and it's just extremely rewarding.
Mm-hmm. Yeah, I'm super excited for you, and we'll see how it works. I want to pivot into talking more about you specifically as a person. And so one of the things, I think this is a great place to start because I just think it's a fun question. When I spoke to Hugo Amselm, he gave me this phrase that I really called maximize weirdness. And so we were talking about how the internet lets people jump down different rabbit holes and find their community and maximize their weirdness. So my question is just, how does the internet help you maximize your weirdness?
Yeah, it's hard to say how it does. You can find like a lot of really small communities that are like focused on one really awesome, like obscure thing that no one else knows about. I think as people on tech Twitter and like in that like startup ecosystem, we see that a lot. But the general public is still, TikTok's fun, don't get me wrong, but they just use that, or like when they use Twitter, they're like just following the normal like celebrities or whatever. Like whatever's going on with Kim Kardashian, like Kanye West's divorce or whatever, or like some kind of drama there. Whereas we tend to find like these very specific verticals where you have crypto Twitter and people are talking about Bitcoin all the time. And you can encounter the Bitcoin maximalist community and see what they think. And that's a really interesting space. And I think like crypto like tends to attract like the most eccentric people ever.
Yes.
If you think about it.
I saw, it was the funniest tweet. It was like people can't pay for therapy, so they make Bitcoin their religion. It was something like that, but it's just so funny.
Yeah.
It's so true though.
Yeah. That meme has some truth to it. But yeah, I think that you can find all these like small communities and get involved with them. And these are people that you normally wouldn't be able to find in real life, or even if you did meet them in real life, you wouldn't know that they're interested in the same topics you are. So it's like often like what's funny is like I can join, I don't know, you're probably familiar with Z Mafia.
That was going to be one of my next questions. Yeah, but go ahead.
Yeah, that's one Discord where it's like just full of a bunch of like younger like Gen Z people who are interested in just building things. And it started as like a Twitter group chat and ended up becoming a Discord and like blowing up in this huge thing.
Yeah.
And we got in the New York Times for it, but some of the coverage wasn't great. Like it's like weird. It's like you're in this Discord server and then you see like an article about the Discord server. Like that's crazy to see like
right.
a New York Times coverage of our Discord server. And it wasn't like really, I think that was like a surreal moment, but at the same time in that community, you're able to, what was interesting is I was able to find people in the Midwest, actually, where I'm in Ohio right now. And I was finding people in Kentucky and in Southern Ohio that I normally would have, even if I found them in real life, and actually some of them I did know in real life, I wouldn't have known that they were interested in technology the way I was. So that was pretty cool.
Yeah, I started this with, I saw this tweet by you, and without me knowing you immediately I could make a connection in that I can see what this person's interested in and what they try to align their life around. And that's very powerful, because if we met in person, what's the likelihood that would come up? But immediately I can know that, and now I'm talking to you about it. And I think it's so powerful. But yeah, to talk about GZM, it was so interesting. I think the 5th person I interviewed was Sudarshan. The 18th person I interviewed, and you're the 25th person I interviewed, but the 18th person I interviewed was Nicholas. And so I guess I joined maybe a little bit on the later end. I think there was already like 1,000 people on the server at that point, but it was weird. I felt like I was talking to like famous people or something. And I got little tidbits of the story there, that it was like a 60-person Twitter group chat. And they were like, oh, like we broke the limit. We got to go with more people. And to get your thoughts on it, but the reason it was so powerful to me was just, I think there's this dystopian sense around technology right now, and being a part of that group made me so optimistic. And that was one of the biggest things that I took from it. And then to see negative media coverage about it, it was perfect because it encapsulated the problem.
Yeah, I think that, I would say that it was really refreshing to see Gen Z Mafia, because they were like one of the only like tech optimist communities that were being talked about. You see tech optimist personalities on Twitter. You see Mike Solana, like the whole like Founders Fund squad, basically, that are really tech optimists. And other VCs or like founders or people in the tech industry talk about tech optimism, but I haven't seen like a community where that was like one of the core values of operating, where it's entirely focused on like people like coined the like Mark Andreessen let's build kind of phrase. But I feel like Gen Z Mafia like truly believes that. Like a lot of the people like really share that value of let's just put our heads down and create something really cool. And yeah, so that was like really refreshing for me. And speaking about all these like famous people, I felt like that on Twitter. Like when I was like on Twitter, I was like afraid to respond or like comment on people's threads, because I was like, I'm gonna probably say something like really dumb. So I didn't tweet for a long time. I spent like a good couple of years on Twitter lurking. And then when I joined Gen Z Mafia, and I realized, okay, yeah, these people are like larger than life sometimes, but then you also get to see like the mistakes people make, and like people like stumble through them, and ultimately they come out on top because they can like persevere through it. But you see, people aren't like invaluable. And then that kind of gave me the confidence, like, okay, people can tweet, then I can tweet too, and I can go ahead and start tweeting. And I think since I joined Gen Z Mafia and started tweeting, like I easily like 4x my followers on Twitter.
Yeah.
And got my ideas out there. And I wouldn't be sitting here talking to you if I hadn't joined Gen Z Mafia, because I wouldn't be tweeting.
I mean, your Twitter content is great, but yeah, it's hilarious.
It's a bit questionable, but
it's a bit questionable. Okay, for the sake of this interview, your Twitter content is great, but no, it's funny. I mean, I think the mistakes part is even more valuable, because you can see that it's a real person just trying to figure it out, just like you, and messing up. And some of the stuff they do is great. Right? Like when Sudarshan tweeted like, oh, I've met a lot of VCs, would love to give people access, stuff like that. I'm like, that's a great thing to do. But then you see maybe him or other people that are doing great things make mistakes sometimes. And so you see the two sides of it, the incredible intentions and the drive to make it happen, but also just the human part of it. And that wasn't necessarily helpful for me on Twitter. I still don't tweet that much, but it was helpful for me in just thinking about creating something in general and understanding how we need innovation to drive this country forward in a lot of ways and expand the pie for a lot of people. Yeah.
And I think like a lot of the people who like are like anti Gen Z Mafia, like they also have flaws and stuff, but they expect everyone to be perfect. No one's perfect. I think we can try our best to be close to perfect. Every time like people are going to make mistakes, they can learn from those mistakes or not. And I think it comes down to, if you're going to redeem yourself, it just comes down to learning from your mistakes and not repeating them. And so the standard shouldn't be like, oh, people are like, can't make mistakes. The standard should be like, okay, you made a mistake, you learned from it, you can move on. And I think we've seen that in the tech industry, like just coverage over tech overall. Occasionally a tech company will mess up or say the wrong thing and get a bunch of backlash for it. But then they generally tend to go out and try to fix it or try to address it and acknowledge that they messed up. And the thing is, I think the media kind of expects like everything to be perfect all the time. And that's not true.
Yeah. And to be honest, I don't know if I was even plugged in enough to understand all the activity towards GZM. It was very surprising to me when I found out that people took issue with, how could you have a problem with it's time to build? That's an amazing thing, because it's just a community of people that are trying to create things. And so what could you have against that? And then I started hearing these weird stories about Sudarshan, for example, people trying to cancel him for having a hackathon, which is, I guess in some sense, I understood where people were coming from, but a hackathon is a great thing. I thought that was an established thing. And so it was just bizarre for me.
Yeah, absolutely. I think the problem with a lot of people who criticize tech is they think, oh, tech is bad. And then they use things to rationalize it, their worldview. And they're not really focused on like actually trying to improve the issues within tech. Where you could say the hackathon might have some issues sometimes with some of the ways they might be run or set up. But instead of saying hackathons are bad, you can say, okay, let's just fix some of these issues within running a hackathon and that culture or something. I think I would consider like people who criticize tech to be more altruistic if they like pointed out, here's the small like micro corrections we can make to actually improve it for everyone. But instead they're like, no, progress is bad, capitalism is bad, technology is bad, and they go that route. So I don't trust that viewpoint until they're like able to say, okay, here's the small changes we have to make.
No, I definitely agree.
My AirPods just cut out there. Okay, they're back. Sorry.
No, it's all good. It's all good. I've had totally worse things happen. One time, Same's Wi-Fi completely cut out, and so he left the broadcast he left the recording for a minute. But yeah, I totally agree. I think it's one thing to talk about the necessity for creating shared spaces and using inclusive language when it comes to invoking different races and genders. But it's a totally different thing to create an organization that then has to actually think about what sort of language do we use to make people feel included, because it's difficult and you're going to make mistakes. And so we did get a little bit off track from what I actually wanted to talk about, but I appreciated having someone to share that with, because it was odd to me too. But I guess the last question I typically ask in my interviews is just, what excites you the most about the future?
Yeah, I'm really excited for space. I just want to go to space so bad. So I'm really excited for that. And I think that if we saw technology, I haven't been around for too long. I've been around for 20 years. So I can't say much, but it's even from what I can remember in 2005 or 2010 even, like everything was completely different. The way people acted was completely different. And in the future, I think people will act very different too. And I think that if we set like really long-term goals, like going to Mars or something, then it kind of gives like humanity as a whole some new goal or mission or aspiration to work towards. Like I think in the modern world, people kind of view like, okay, this is like the peak we can be at. Everything's been solved. And that's just not true. I talked about it with picking like the low fruit and how the tree always grows. But I think that by setting like goals to go to Mars and like setting up an establishment on Mars and a city on Mars, that's a very ambitious goal. And people will say, oh yeah, you can't do that. It's impossible. Like the technology's not there yet. But setting that goal is just something that it sets a new thing that we can work on and work towards. And it gets people like fired up about the future, including me. Like I'm super excited to hopefully one day be able to visit Mars, and maybe we can use some metal printers on Mars or something. I think that'd be really cool.
Yeah.
So I'm really excited to see all the cool things that are out there in the future and how like people interact in the world like that, especially like with transportation. And what I really want to do is see like a world where when transportation is like super fast, like where I could live in LA and then I could commute to my work in San Francisco, or like the opposite. Or even to give an even crazier example, like I could live in Ohio and my job could be in New York. And I'm not even talking about remote work. I'm talking like you get to physically go there. Transportation should be so fast that we can go do that. And I think that you're going to be able to meet like so many cool people, and like the real physical world will be a lot more similar to the digital world, where you can find these like weird like niche groups and explore that. I think that technology will enable this like weird fusion of what we've seen in digital progress in the physical world in the future. Yeah. So I'm really excited to see that.
Yeah, I love that. I think the internet made the world feel like one big city, and then you could make physical reality feel like one big city too. I think that's amazing. And I think it's definitely people like you and people that are actually creating definite plans for the future to make our species multi-planetary and to innovate across all of these fields, that it's exhilarating to actually set a goal like that and then to start make progress towards it. So yeah, I really appreciated talking to you, and thanks so much for talking to me about Vuecason and also just talking to me about yourself. I really appreciated that.
Yeah, thank you for having me. This was actually a great conversation. I loved it.
Yeah, appreciate it. All right, take care.
See you. Bye.